Hello, my dear students. Welcome to IMS GATE Academy, GATE Foundation on Digital State. So, in this particular session, we will start regarding K-Maps. So, this topic is common for all the 4 branches: electrical, instrument, computer science. So, kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this. So, first of all, let us see what are the topics that we have discussed in the last class. In the last class, we have discussed regarding properties of min terms, and then we have discussed properties of max terms, and then we have discussed regarding the algebraic expression. Whenever you are having the truth table, yeah, good evening. Good evening, sir. How are you? Have you watched the last class? Time? Fine, very good. Yeah, whenever you're having the truth table, okay, that time at the input side, you will be having the number of variables, and similarly regarding the outputs, you'll be having, based upon that particular circular system, you'll be having n number of variables. Each and every output variable we can represent either sum form, that means sum of min terms form, or we can represent product of max terms. That means you will observe the input combinations for which you are getting output as 1. Okay, those input combinations are nothing but min terms. After that, you have to sum together. Yes, very good, Isaac. And you can observe the input combinations for which you are getting output as 0. That means the respective combinations are nothing but max terms. Those max terms we will multiply. Here pi stands for product and sigma stands for sum. Okay, so initially from the truth table, you can represent the output variable either sigma m form or pi capital M. Yes, good evening, sir. Okay, so after that, after simplifying any Boolean function in general which is represented in sigma form, after doing a simplification, you will get SOP. That means sum of products. Here you are having the product terms, here sum together. Whereas initially you are having min terms sum together. After doing simplification, any particular min term, if the number of literals getting minimized, then we will call that particular logical and term simple product term. Since those product terms are summed together, it is S. And similarly here, after doing the simple pi capital M, we will get POS. In general, when you are having sigma m, after doing simplification, get SOP. Similarly, if you are having pi capital M, after doing get POS, right? Similarly, you can do the reverse. Suppose if you are having SOP form, you can convert into sigma m form based on the requirement. Similarly, if you are having POS, we can convert into pi capital M. So, in one of the previous session, we have discussed if you are having sigma m or pi capital M, how to do the simplification. Regarding that, we already discussed with the help of basic rules class of Boolean algebra. And in the last class, we have discussed whenever you are having SOP form, how to convert into sigma m, or if you are having PY, how to convert into pi capital. Okay, so these conversions we have discussed in last class. That means whenever you are having the truth table, for each and every output variable, based on the requirement, you can represent with any of these 4 forms. Okay, initially from the truth table, you can represent sigma m or pi capital M. After doing simplification, get SOP or POS. Okay, the significance of SOP and POS you will come to know in the logic gates chapter. Okay, so I hope up to this point it is clear for everyone. If any of you couldn't attend the last session, kindly watch that particular lecture in your. Okay, in the last class regarding this concept, how like if you're having sigma m, how to write pi capital M, or if you're having pi capital M, we can write sigma m, vice versa. Okay, and then we have discussed pi capital M like that. We have discussed in the conventional approach, and then we have discussed shortcut method also. Okay, so with the help of shortcut method, easily you can write. You can represent SOP into the sigma m, similarly POS into the pi capital. I hope it is clear for everyone. So now in this particular session, first let us start. Okay, let us discuss few questions based upon this topic, and then we'll continue the further topics of algebra, and then we'll discuss the K-maps. So this is the question asked in GATE CS 2010 for 1 mark. So all of you try this question. Yes, very good, Isaki. Very good. Option A is the correct one. Option A is very good. So here, if you observe the question, it is given regarding the Boolean f of p q r. You are having one Boolean function, like you observe here, you are having product terms sum together. Here, you observe the number of variables are 3, but in each product term, the number of literals here you are having simply 2. Okay, so that means the moment if number of literals is less than the total number of given variables, we will call that particular logical and terms simply as product terms. That means here you are having 3 product terms, they are summed together. That means the given function is SOP form. The given function is SOP form. Now they are asking the corresponding minterms expression. That means whichever minterms you are having, those minterms you have to sum together. That means IM they are asking. So this question is related to SOP to conversion. SOP to. So regarding this particular method, we have discussed in the last class in conventional approach, and then I have discussed shortcut. Now I will discuss, okay, I will solve this question with the help of shortcut. So first of all, whenever you want to write the min max terms, the order of the variables is very, very important. Okay, so here PQR are the 3 variables. That means among these 3 variables, P is the MSB, whereas R is the LS. So first of all, write the variables order as it is, PQR. Now consider term by term. Okay, the first term is what? PQ. First term is, that means while you are considering min terms, okay, you are having variable is normal, that means value is 1. Okay, here both P and Q are normal, that means the corresponding variable values are 1. Here R is missing. So regarding R, you will get 2 combinations. R can be 0, R can be. So that means here you are getting M7. 2 minterms you are getting. M6, M7 present here. M6, M7 present here. M6, M7 are not present in option B, option D. So with the help of the product term PQ, the moment you are getting 2 minterms. Okay, for this question, when you look at these 2 minterms in all the choices, only in 2 choices you are having those 2 minterms, whereas in other 2 choices you don't have. So directly you can eliminate choices, option B, option D. This way, whenever you are solving any question, so with the help of partial solution, okay, especially when you're having MCQ, obviously you're having choices in front of you, just have a glance. Sometimes there is a possibility to the wrong choice. Next term is what? Q into R bar. Q into R bar. In this case, Q is normal, that means Q value is 1, whereas R is in complement, so that means R value is 0. When you substitute these 2 values, here you will get resultant output as 1. Okay. So here regarding P, you will get two combinations. Can be 0, P. So 0, 1, 0 is nothing but 2 and 1, 1, 0 is nothing but. So what are the minterms here you are getting? After that we will sum together. That means x plus x is nothing but x. So in this way, if any minterm repeats, you can consider one time. Okay. So in addition to M6, M7, we are getting one extra minterm, that is M2. M2 is present here. Whether M2 is present in option C? No. That means option C also we can eliminate. So with the help of this particular term, we are able to eliminate one more wrong choice. So since we are able to eliminate three choices, obviously one option is that will be correct. Okay, whether it is correct or not, let us proceed further. Now we are having one more term. So I am considering once again. The last term is R bar. R bar. So here P value is 1, R value is 0. Regarding Q, you will get two combinations. Can be 0, Q. 100 is nothing for 110 is. So M6 is already here, so you can consider one. So extra we are getting M. Here we are having total 4 minterms. All the 4 minterms we are getting M2, M4, M2, M4, M6. All these minterms you have to sum together. That is nothing but sigma or sum of minterms. So it is very easy question. The correct answer for option E. I hope it is clear for everyone. So let us move on to the next question. So all of you try this question. Yes, very good, Isaki. Very good. Option D is the correct one. Question asked GATE is for 2 marks. This question they have given one Boolean expression A plus B bar, and they have mentioned here which is equivalent to. So here you're having 4 choices. Option A, you're having options like this, 4 choices. Now just observe, since they have mentioned here equivalent to, that means expression and one among the 4 choices that should be equivalent, right? So you can verify option by option. Okay, so you can do the simplification from there, whether you are getting this one or not. Like that you can cross check, or with the help of whatever the method just now we have told, the given function is SOP, the given. And here if you observe regarding sigma m form, okay, here you're having 3 choices are like sum of products form, and 1 choice you're having sigma m form. The function of variables here in each and every term you're having 3 letters. Okay, so this function is. So first let us verify. Either you can bring SOP to sigma m, or from sigma m you can get SOP. Okay, so you're having 2 choices. Either you can follow SOP to sigma or sigma m. For example, I will solve from sigma. So just observe. Suppose if you're having this function, they ask that just do the simplification. How you will do? You will observe the common terms. Yeah, yeah, yes, okay. I will answer that. First, let me complete this regarding option D. So option D, you're having total 4 terms. So just observe the first and third term. First and third term. From these two, you can take AB as common. Then you are getting plus or plus. From the second and last terms, you can take okay, there is some, I think, small typo mistake there. Let me cross check. The first and last, second. Yes, very good. So first and last, if you observe, we can take AC as common, and from middle two terms, we can take B into C bar as common. So if you take AC as common, then B plus B bar is 1. Then from these two, you can take B C bar as common, A bar plus A. That means you are getting AC plus BC. Okay. So from options you can do. That means IM to SOP, or otherwise the other method, whatever we have discussed, SOP IM, with the help of that also you. Say for example, first of all, write the variables order as it is, ABC, and here the first term is what? A. First term is A. That means A value is 1, C value is 1. Regarding B, you will get two combinations, right? So B value can be 0, B value can be. So here you are getting two minterms. 101 is 5, 1 is 7. Okay, so just observe. Okay, we'll come back here. First, let me complete. Regarding the second term, you are having B into C or B into C. So that means here B value is 1, C value is 0. So regarding A, you will get two combinations. Can be 0, 0, 1, 0 is 2, 1, 1, 0 is. So total we are getting 4 minterms. Minterms 2, 5, 6, 7. 2, 5, 6, 7 we are getting. Whether all the 4 minterms are there, the option D or not, let us. So here 111, that is nothing but M7. Yes, we are getting this term. Next 010, that is nothing but term 2. We are getting this term. Then 110, nothing but 6. And then 101, but 5. Yes, we are getting all the 4 minterms. All the 4. Yeah. So for this question, either you can do just by observing this one since SOP form, and when you observe the 4 choices, out of which 3 choices are in SOP form, whereas 1 choice in 6. Okay. So first of all, you can give a try either SOP or segment SOP. So with the help of that, okay. So here with the help of SOP, directly you are getting option D. So Taki was asking whether option A in option, whether we can apply consensus or not. So just observe here from first and last. From first and last, suppose regarding option A. Regarding option A, first term and last term, you can take C as common. If you take C as common, A bar plus A what? 1. Okay. Then B into C. So you can apply distribute law here. You get C plus B is 1. So you are getting simply one sum term, that is C. No need of consensus. Any doubt is regarding option? Yeah, here, right. So sometimes the question they will specify directly, right? They will give SOP form and they will mention that try to identify the equivalent sigma m form or pi capital M, etc. Sometimes they will give sigma m or pi capital M and they will ask try to find the minimized function. Okay, so in that way directly the main keywords are there. With the help of that directly you can do the conversion according to the given question. But sometimes instead of directly mentioning that, okay, they with the help of this keyword, since they have mentioned equivalent, so you have to verify option by option whichever function after doing simplification, if one or with the help of simplified function, if you are able to write this one, then we can say those are equivalent, like that. So whenever they don't mention direct that keyword, either segment SOP conversion, so that time you just recall this Padé concept and try to verify, because one of the option you are having here, so either you can do SOP to sigma or sigma. Fine. Question, all of you give a try. There are n Boolean variables. There are n Boolean variables. Then we can generate at most dash number of Boolean. How many Boolean functions at max we can generate if we are having n Boolean variables? Yes, very good, Isaki. Very good. Option D is the correct. In the last class, we have mentioned that, say for example, there are n Boolean variables. There are n. Then there will be for n min. Then there will be for n min. And if you want, with the help of n Boolean variables, you can generate 2 power n max. Okay. After that, what we are doing, whatever the min terms you are getting, those min terms based upon your requirement will sum together, right? So like that, all the possible cases consider. So that means now we are having n Boolean variables. With the help of n variables, okay, with the help of n variables, you are getting 2 power n combinations of zeros and ones, right? So that means for each and every combination, if you are getting output as 1, the maximum case, you are getting the total number of min terms possible with the help of n Boolean variables is 2 power n. Now you can assume this 2 power n is something like x as another variable x. Now if you are having x min terms, with the help of x min terms, how many Boolean functions at max we can generate? Okay. So with these foreign min terms, we can generate okay, if you are assuming for n is something like x, just like here, I have considered n variables. With the help of that, we are getting 2 power n. In a similar way, we are assuming this 2 power n is something like x. Now, if you are having x min terms, now we can generate 2 power x Boolean functions, where x is nothing but 2 power n. Where x is nothing but Okay. So that means if you are considering n value 2, say for example, if you are considering n value 2, then with the help of two Boolean variables, we will get 4 minterms. Okay. If you are having 4 minterms, with the help of that, we will get 2 power 4, which is r. Directly, if you substitute n value 2 here, 2 square is nothing but 4, 2 power 4 is nothing but like that. Okay. The answer for this question is option D. So now let us see regarding the Boolean functions of two variables. Okay. So here I have considered n value is 2. That means with the help of two variables, we are getting 4 minterms. We are getting 4 minterms. Those are m0, 1. These are the 4 minterms we will get. We have discussed regarding these having two variables, then we are getting 4 minterms. Now, if you are having 4 minterms, with the help of 4 minterms, you can generate 60. So that particular value you are getting just by substituting the n value 2 in this particular formula. Okay. Now I will give one more logic also, how we are getting that 60. Later you can verify whether we are getting all the 60 or not. You can verify later. But just I am giving one more logic here. With the help of your mathematics, you might study like permutation combination, right? So with the help of combination concept, now we will get the same answers. Say for example, here we are having 4 minterms. We are having 4 minterms. With the help of 4 minterms, we have to generate various Boolean functions. Okay. Say for example, here out of 4 minterms, okay, in one particular combination, I am not choosing any minterm at all. I am not choosing any minterm at all. That means 4C0, 4C0. Okay. Another set, I am considering like this. Out of 4 minterms, at any time, I am considering only one minterm. I am selecting only one minterm. That is 4. And similarly, out of 4 minterms, you can select any two minterms like m0 plus m1 or m1 plus m2 or m2 plus or m3 plus like that. Okay. Similarly, out of 4 minterms, you can choose 3 minterms at a time like m0 plus m1 and another one is m1 plus m2 plus like that. Okay. Out of 4 minterms, you can choose only 3 minterms at a time. And then the last possible, out of 4 minterms, all the 4 minterms we will. Is it clear, Isaki? We are having 4 minterms. I am giving one more approach in order to get the same answer 16. The earlier I have discussed one formula. With the help of this formula also you will get 16. Now I am giving one more hint. Okay, one more approach how we are getting this. Okay, now 4C0 we can write it as 4C0 is nothing but what? 4C0 is but 1. NC0 is nothing but 1. Next, 4C1 is nothing but 4. 4C2, we can write it as 4 into 3 divided by 2. Here suffix you are having 2. That means you will start from this number, just reduce that number by 1. Okay, like that, how to continue up to this particular number of times. Here you are having 2, so that means I have started from 4 and next number is just decrease by 1, 3. And similarly here, start from this number and go up to 1. Next, 4C3 we can write it as, we are having NCR. What is the formula? NCR we can write it as NC. Can we write like this? Hope you might start in this. NCR equal to NCN minus, right? So with the help of that logic, 4C3 can write as 4C1. 4C as 4C1. Sir, no. 4C 4 minus 1, right? So 4C1 means just now we have discussed, that is nothing. Next. Now can you tell what will be this? 4C4 with the help of this formula, it is same as 4C 4C0. 4C 4 minus 4, but 4C0. 4C0 is nothing but 1. Okay. So 1 plus 4 is 5. 1 plus 5. So 5 plus 5 is plus. Here 2 times in Boolean. So we are getting the same answer. Okay, if you are having two variables, with the help of two variables, we get 4 minterms. By using those 4 minterms, okay, we can generate maximum in Boolean form. Later in your free time, you can consider whatever the sets we have considered. So with the help of that, just write all the cases. And for the timing here, I will give the direct expression. Whatever we are able to get, all the 16, I will directly give. So later, whenever you are having free time, so just make one tabular form, or otherwise, whatever the approach here I have mentioned, with the help of this approach, just try to write all the possible cases. Like say, for example, here we are not choosing any min term. We are not choosing any min term. That means always you are getting output as 0, like that. Okay. Similarly, here we have chosen all the 4 minterms, all the 4 minterms. That means if you are adding all the 4 minterms, what is the resultant value you will get? What is the resultant value you will get? Sum of all minterms. That is the property we have discussed last class. Sum of all minterms equal to sum of all minterms equal to 1, right? Right. So that means for all the input combinations, at the input side, you are getting output as 1, correct? Right. So like that, for this particular case, you are getting only one function. Similarly, for this case, you are getting only one function, right? Like that, here, suppose for 4C1, you are getting 4 functions. For 4C2, you are getting 6. For 4C3, you are getting 4 functions, right? So you can write all those cases, try to do the free time. Okay. So for the timing, I will write whatever the 16 possible functions after doing the simplification. Okay, some functions you can directly write from the truth table or just by observing, or otherwise what you can do at the input side, you are having the minterms, right? So by adding whichever minterms you are getting output as 1, those minterms we will sum together. That's the help of sigma m concept. Sum of min, you can do the simplification. Similarly, the same concept you can do with the help of max terms. That time, whatever the max terms you are considering, those max multiply, right? So now I will write first of all, suppose here we are focusing what? Two variables. Say for example, when you are having two variables, so for the timing I'm considering regarding two variables. Okay. What are the possible cases? A and B, then A and B bar, A bar B, A bar. These are the 4 possible cases. Okay, when you consider logical and finally here the corresponding logical OR plus B bar, A bar plus A bar plus. Okay, here you are getting 4 functions, here you are getting 4 functions. As of now, we got 8 functions. After that, say for example, here if you observe A and B, that means in order to implement function, you will AND gate. Okay, in the chapter we will discuss regarding logic gates, and every gate got the respective based on the function that is produced. Similarly, if you are having A plus B, for implement this one, we will OR gate. Okay. Now tell me, A bar, B bar, we can write it as A plus B whole bar by using. Similarly, A bar plus B bar by using De Morgan's law as AB bar. Okay. So that means here you are having what? You are having logical and on top of that you are having complement. So that means if you want to implement this particular function, we will use NAND gate. Similarly, here you are having A plus B. After that, on top of it, you are having complement. So for implement this one, require NOR gate. And then the last class we have discussed one truth table. The truth table is corresponding to XOR gate, right? XOR gate. So A bar B plus A into A bar B plus bar, that is nothing but A XOR B. So for implement this function, we will use XOR gate. Similarly, you will be having A bar B bar plus A bar B bar plus A, nothing but A XOR B. So for implementing this one, we will since the given function, it is a function of two variables. Okay, so I started with the help of two variables. I have written logical terms and corresponding logical terms. After that, okay, here I got AND gate, OR gate, then NAND gate, NOR gate. After that, you are familiar about XOR, XNOR. So accordingly, I have written the okay. So this whatever here I have written, that is with the help of two literals. Two literals. That means here literal means either the variable normal form or complement. Okay. After that, okay, whenever you are doing a simplification, okay, here you may get the simplified functions like this. So up to here, you count here four function. There 8, and then we have discussed two more. So as of now, we got 10 functions. 10 functions. Okay, all these 10 functions are depending on two literals. All these 10 functions are depending on, but in general, if you are doing the simplification, after doing the simplification, you may get single literal also. See, the maximum possibility is what? Since there is a function of two variables, after doing the simplification, you may get two literals. That is one possibility. Another possibility is what? You may get single literal, or after that, one more possibility, not get any literal also. Correct? Okay. So all these functions, whatever I have written, all the functions. Now let us focus single literal. That means after doing simplification, we are getting like simply or A bar, or we are getting a minimized function like this. That means here you are having single literal. Okay, and so initially we have discussed after doing simplification, you are getting two. Here you are getting single literal. Now one more possibility is what? No literals. No literals. That means, or you can say zero literal. So zero literal means what? You should not have the function either normal form or complement form. Now can you guess what are the possible minimized functions which you can get which contain no literal? Contains no literal. Yes. Here we got 10 functions and here we got 4 functions. 10 plus 4 is 14. That means 2 more functions. Can you guess what are those 2 functions which are not having even single? I already mentioned here, if you observe the first case and last case, with the help of these, here we are having total 4 minterms, but I haven't chosen any minterm. That means always I am getting output as 0. In another case, I have chosen all the minterms. That means for all the input combinations, we are getting output as 1, right? So that means here last case, so here 1. We are getting always 0. That is output we will write 0. We are getting always output as 1, irrespective of the input combination. Or for all the input combinations, we are getting always 1. Directly you can write output as 1, right? So these are the 16 functions. 10 plus 2 plus 4. Total 16. Now just observe these relations. Either you can observe left to right or right to left. What is the relation for each? Just observe the arrow marks either from left to right or from right to left. What is the relation between them? Yeah, Isaki, it's complement. See, for AB, if you apply De Morgan's law, or if you put complement, you will get what? AB bar. Similarly, for A plus B, if you put complement, you will get A plus B whole. But here you are getting, just observe here, in this particular set, you are having logical and operator. This particular set, we are having logical or operator. Wherever logical and is there, we have replaced with logical or. Correct? And similarly, here you are having 0, we have replaced with 1. That particular two steps, if you are applying, and what is the function you are going to get? Wherever, just by interchanging logical and or, and by interchanging 0 and 1, what is the function you are going to get? That is a dual. Yes, very good. Well, dual to each. So all these functions, whatever we have discussed here, all these functions are dual to each other. Okay. Now tell me, what is the dual of A? What is the dual of A? Yes, very good, Isaki. Very good. Dual of A is A only. Actually, dual of A bar is A bar only. Dual of B is dual of B bar is B. Because here, while we are applying duality, what we have done? Whenever you are having two variables or two literals, among two variables, we are performing one basic operation. The basic operation can be either logical and or logical or. So that particular operator we have interchanged. But here you are having only single literal. When you are having single literal, there is no question of the binary operator. Yes or no? There is no question of, there is no requirement of binary operator, because here you are having only one literal, right? That's why there is no need of interchanging the operator. Even if you interchange, that means since there is no binary operator, obviously there is no question of interchanging. So that means obviously you will get this, because here whatever the literal you are having, exactly same form we have considered. For A, A only. For B, B only. For B bar, we have considered B bar only. Correct? So that means whatever the variable, either if it is a normal form, we have considered normal only. If it is in complement, we have considered exactly complement. We haven't modified the variable to complement or complement of normal, right? So only we have interchanged the binary operator. Since you don't have any binary operator here, obviously for each function, you will get the same function. That means after applying dual also, for the given function, if you are applying dual, if you are getting the same function, then we will call it as self-dual. Self-dual. The heading self-dual. Just make a Boolean function self-dual. The given function, and the corresponding given function and the corresponding given function corresponding dual function correspond, both are same. That means the original function and after applying dual, if both are same, then we will call the given function itself is the dual. That's why we are calling it as self-dual. So if you want to represent mathematics, you are having original function f. If you are applying dual, that one we can represent as f. Here d for the original function and the corresponding dual function both are same. So here examples are examples if you want, right? A bar, B. For these four functions, the original function and the corresponding. Okay. Now, with this understanding, try this simple. Only one option will be right. Just give it a try. I hope all of you can just read the question. You can mention whichever option you turn to you, whichever option feel correct, you can. Yeah, Isaki, you can cross check. Just read the question. Here, what they have mentioned, you have to identify the pair of two input logic gates that are dual to each other, and complement each other. Are dual to each other and complement each other as. Okay, right. So just observe regarding AND gate, NAND gate, we have mentioned these are complement each other. AND gate complement is NAND gate. Similarly, OR gate complement OR gate. Okay. The similar way, XOR gate complement, just like AND gate complement is NAND, OR gate complement is NOR. In the same way, XOR gate complement. Okay. What about NOT gate complement? NOT gate complement, you will get buffer. No. NOT gate means get A bar. So for that A bar, once again, if you are performing complement, so 2 times NOT gate if you are using, okay, one NOT gate, after that one more NOT gate. Okay, the output of one NOT gate, the overall configuration is called as buffer. That means having A bar here, complement of A bar is nothing but A. So that means whatever here we have given in that, whatever the pair of gates you are having, all the pair of gates are complement each other. Now, but here in the question, right, they're equal to each other also. How to identify the pair of logic gates which are complement each other, equal to each other. For AND gate dual is what? For AND gate dual is OR gate. That means AND gate, NAND gate are not dual. So option A. Similarly, for OR gate dual is AND gate. Okay. So that means here mentioned OR gate, NOR gate. So now for NOT gate, okay. See, when I asked you previously, for A, if you are applying dual, you are getting A only. You have mentioned A only, but here for answering here, you have done some. Here you are having NOT gate. If you apply dual, you will get NOT gate only. Similarly, for buffer, if you apply dual, you will get buffer only. But here you are having for NOT gate dual is buffer, for buffer dual is NOT gate, but that is wrong. So option C. So here only one option is left, but that is okay. And here if you observe, here I already mentioned, here left hand side you are having XOR, right hand side you are having XOR for dual to each other. Whether these are dual to each other or not, let us see now. Okay. So first of all, I will write A XOR B. That is nothing but A bar B. So just apply dual to this. Just apply dual to this. Wherever logical AND is there, replace with logical OR. Wherever logical OR is there, logical AND. Okay. So A bar into A, 0. A bar into B bar. Bar into plus. B into A we can, and B into B bar is nothing but 0. So A bar B bar plus AB, which is nothing but A XOR, but A XOR. So that means A XOR B dual is A XOR B. Similarly, for A XOR B dual is A XOR B. And earlier I have mentioned that just like AND gate, NAND gate, OR gate, NOR gate, same way XOR gate, XNOR gate are complement. Whether those are complement or not, let us see. For example, I am considering A XOR B and forming complement. So we should get A XOR. Once again, write A XOR B formula, that A bar B, A into B. You are having complement. So by using De Morgan's law, here you are having two terms. The first term complement, second term complement. First term complement, here logical OR is there, logical AND. Then second term complement. First term is A bar B, A into B. Now once again you can apply De Morgan's law here and here. Here first term, if you apply De Morgan's law, A bar whole bar, that is nothing but A plus. Here logical and you will logical B bar. Then here A bar, hope it is up to this. I have applied De Morgan's law. Once again, I require the De Morgan. Now, A into A bar, you will get 0. A into B, you are getting A into B plus bar into A bar, we can plus bar B bar. Then B bar into B is, that means you are getting AB plus A bar B bar, nothing but AX naught. But okay. So in general, whatever may be the number of input variables you may consider, okay, always AND gate are complement. Similarly, NOR gate, OR gate are complement. And for buffer and NOT gate, you are having only one input. Okay. Similarly, just like here for NAND AND, OR complement, OR NOR complement. In a similar way, for generalized case, whether you are having more than two inputs, whatever may the number of inputs, in general, XOR gate, XNOR gate are complement to each other in general. But only for two input case, these two are complement to each other. As well as for dual to each other also. Only for two inputs, XOR gate, XNOR gate are both dual to each other and complement. Okay. But in general, XOR gate and XNOR gate are complementary. I hope it is clear for everyone. This is a very, very interesting point from this discussion. I hope it is clear for everyone. So if you are having any doubt, you can. If it is clear, you can mention that we can. Yes, very good, Isaki. So this is the theoretical question based on the basic laws of Boolean algebra while we are doing the simplification of any Boolean. So here you have to identify, you are having two statements. Okay, among these statements, which are the drawbacks or limitations of simplifying the Boolean using basic laws of Boolean? You are having four choices. Choose among these. Yes, very good, Isaki. Very good. Option C is the correct one. So, one of the previous sessions we have discussed regarding the simple. There we have used the basic and laws. Okay. Whenever you are doing the simplification by using laws, okay, there is no automatic procedure. That means there is not that there is no only one method. There are the various methods while you are solving the question. You may have to observe the common terms, or you may apply the whichever rule or law while you are simplifying, right? So there is no unique method. And while you are doing the simplification of the Boolean function, okay, obviously for each and every iteration or each and every step, you have to write the and because of that, okay, in order to get the simplified function, it will take more time. Okay, so that means both are the drawbacks. So option C. And even while you are doing the simplification, suppose if you are forgetting wherever complement is there, if you are considering as a normal variable, okay, and there are more chances to get the errors while you are using the basic rules and laws in order to simplify the Boolean function. These are the drawbacks of the basic laws. Of course, you will get the correct answers, but it is a lengthy time consuming. So, in order to overcome these drawbacks, now we will use one more concept. Can you guess by using which method we can do the simplification of Boolean functions? Yes, very good, very good. K-Maps, right? So all of you put the heading. The next topic is K-Maps. K-Maps, here K stands for Karnoff. A mathematician, he has introduced this concept in order to do this. So according to the name, K-Map has Karnoff map. So first let us see in 2 variable case, 3 variable, 4 variable. First let us see the K-Map, then we'll discuss the simplification procedure in this. And based on the time possibility, we'll discuss one question also regarding this concept. Next class, we'll discuss variety of questions regarding K-Map. So first let us see the one by one K-Maps. Here I am considering 2 variables. That variable by default it is the MS. Unless otherwise in the question they will specify whichever variable is the MS or which variable we have to consider. Whenever you are having alphabets, among alphabets, whichever alphabet is the starting one, that alphabet we have to consider. Suppose if you are having the numbering, suppose A1, A0 we are having. Here we are having alphabets. Okay, in the same way, of A, B, they have given A1, A0. Okay, here you are having suffix value as what? Numbers. Among these numbers, whichever is the larger, among these numbers, whichever is the larger, by default you can consider that. So this is the concept in general we will follow. Okay. Even in the GATE exam also, while they are framing the questions, okay, whenever they don't specify among the given variables which variable we have to consider, okay, by default they will follow this. Having alphabets, among alphabets the starting letter, we are having the numbering, among the numbers whichever number is the large. So here we are having 2. So when you are having 2 bits, get 4 combinations like 0 0 0 1 1 0, right? In the same way 0 1 1 0 1 1, right? All the 4 combinations. Okay, so for the timing I am representing terms, same concept will be applicable with respect. So here M0, M1, variable K. Here variables MS. Here 0 1 1. So what is this particular code 0 0 0 1 1 1 1? For 2-bit case, this particular code belongs to 0 0 0 1 1 1. First chapter we have. Yes, very good, Isaki. It's gray code, right? Very. So if you observe here, whatever the if you are going from one column to the next column, only one bit is changed. Okay, or if you are going from one row to another row, only one bit is changed, right. So that means what are the minterms here we are going to place? All those minterms, either if you observe row wise or if you observe column wise, those are just differed by only one bit only. That means the edges. So here 000, or you can observe here we are having total 3 are there. The moment A value is 0, the moment value is 0, the help of B and C, you will get the corresponding. Okay, because leftmost side 0 is what? Even if you consider that 0 also, you will get the same value. So now 0 0 0 1 1 1 1 0. Right. The minterm numbers are M0, M1, then M2 you get here, then M. General you will write 0 0 0 1 1 0 1 1 in the sequence, but here there is a twist. 0 0 0 1 1 0, because this particular code. Okay, Similarly here for this entire row, here A value is 1. So if A value is 1, the corresponding position weight you will get, when you're having 3 bits, the leftmost bit or MSB is having the position weight 2 here. That is nothing 4. Okay. So whatever you got earlier, 4 minterms, okay, whatever the suffix values you are having, for these suffix values, you are adding 4, you will get the minterms of this particular row. 4 plus 0, that is 4, 4 plus 1, 5, 4 plus. Okay, in this way you can place the min. Here I am focusing with respect to minterms, same concept will applicable with respect. One is 4 variable K-map. Here I am considering 4 variable. Maybe I am keeping here for 2-bit case the corresponding 1 1 1 1 0. Similarly here also I am having corresponding code 1 1. Okay, right. So here if you observe for the first row, you are having AB values are 0 0. So when you are having AB values are 0 0, with the help of C and D, you will get the corresponding. So with the help of CD, you are getting the combination like this 0 0 0 1 1 1 1 0. So in the same way, here also you are having the same combination. So that time here I have considered M0, M1, M2, M3. The same thing you can copy as it is. Copy as. So M1. Okay. So similarly here if you observe, you are having 0 1. For this entire row, AB value is 0 1. After that you are having, okay, or you can easily observe here. Earlier we have considered what 3 bits. Okay. So now I have added one more bit here 0. Similarly here 0. Okay. When you are adding leftmost side 0, that 0 is insignificant, right? So you will get the same row. Otherwise, here regarding 1, that means key position 8. You will observe for 0. Here MS row, and for this particular row, B value is 1, the corresponding position is 4. So just if you are adding 4, you will get the midterms here. 4, 5. Hope up to this point it is clear for everyone. Now just observe the first row and last row. What is your observation point? First row, last row if you observe. What is your observation point? Value we kept as it is. Value we kept 0 only. 0 only. But A value we are modifying from 0. A value we are modifying from, okay. So now A value is 1, that means the corresponding position is 8. Corresponding position. That means if you are adding 8 to this row, you will get the minterms of this regarding suffix value. Okay. 8, 9, similarly just observe the second row is 0 1 and the third row is 1. Third row is, so just observe the second row and third row. Second row, third row. Here P value we kept as it is, 1 only. Value we kept 1 as it is, but A value we are modifying 0 to 1. That means here also we have to consider Okay, so that means whatever the minterms you're having in the second row, you're adding 8 to the suffix values, get the minterms of this particular row. So 8 plus 4 is 12, 8 plus 5 is 10, 8 plus 6, 8 plus. So here in this case, since I have placed AB here, CD here, that's why we are getting the minterm numbers row wise like this: 0, 1, 2, 4, 5, 6, 8, 9, 10, 11, 12, 13. Suppose you have kept AB here, CD here, in that case, whatever row wise minterms you got, you will get column wise. So which method you have followed? Taki BTech method you have followed, whether this particular K-map you have followed or you have kept A, B or CD. First one or second? We are keeping AB at here and CD here. That time, whatever the row wise minterms you are having here row wise, that one you have to place column wise. The form based upon your convenience follow. There is no. Okay. Since you are considering A is the MSB, A is the MSB. Here I have kept A here. You are getting. Yes. First one only, right? Yes. Very good. Row wise. Okay. So I hope it is clear for everyone up to this point. Okay. Whenever you are supposed to do the simplification function with the help of K-map, so based on the number of variables according to the respective. Okay. Now just for understanding, suppose if you're having, if I ask you functions, for example, okay, M4 plus M5, I have given one function, and if I ask you to, we are using basic laws of Boolean algebra, that time what you will represent these two minterms in terms of the variables. Okay, 4 is nothing but 100. That means A for 100. Okay, 100 is nothing. Finally, 5. 5 is nothing but 101. 1 0. Okay. Now you will observe the common terms. From these two, which term we can take common? A B bar C bar. A B bar C. That means we can take A B bar as common. For the terms, A into B bar is the common part. That one is common. After that, you bar plus. So C bar plus C, nothing but what? 1 bar plus C at 1. That means we are getting the. This is the simplification we have done earlier. We are using basic laws of Boolean. Whenever you are supposed to simplify the sigma m function, okay, that time we have to observe the common terms, and to require any other law you can apply. Okay, so this kind of simplification we have done earlier. Now with the help of K-map, we are avoiding this kind of simplification. We are avoiding this kind of simplification, but directly, suppose if you are having two minterms M4 M5, suppose if you are having 2 4 M5, okay, in a function you are having, that means for these two input combinations you are getting output as 1. Okay, now this K-map, first of all you will place the ones for whichever input combination you are getting output as 1. After that, here you can do simple grouping of these, and now you can observe row wise. When you have done grouping of these ones, row wise A value is 1, row wise A value is 1. That means you can write A, because it is the A value 1, that means normal function. And column wise, if you observe B value is 0, for these terms B value is 0, that means it B bar. Okay, what about C value? Here you are having 0, here 1. Okay, since C value is changing, that won't come in the final answer. Now you can observe here, whatever the term you got here, the same term you are getting. So that means here what value is changing. So whatever the variable is changing, that won't come in the final answer. Okay. So that means here we have used internally one property, that is called edge. adjacency property we have. Okay, that is the beauty of K-map. That's why here, whatever the gray code we have placed here, you observe, suppose first column, second column, whatever the min terms you are having, like M0, M1, those are adjacent, M4, M5, those are adjacent. Similarly, second column, third column are adjacent, third column, fourth column are adjacent, even fourth column and first column also adjacent, because the gray code is satisfy even cyclic code also, correct? Suppose if you observe the last column and first column, here C value is 0, but B value is changing, only 1 bit is, okay. Similarly, first row and second row, if you observe, only A value is changing. Suppose M0, M4, M0, M4 are adjacent, M5, M7, like that, okay. So that is the beauty of the K-map. Okay, here we are just simply placing the ones wherever you're having for that particular function, for whichever input combinations one, you just place the ones in the K-map. After that, just do the grouping of edges. Okay. This kind of simplification process going internally, we no need to do the simplification. Okay. We have to we can directly write the simplified expression for that particular grouping. For that particular grouping, you have to observe row wise and you have to observe column wise. Whichever variable values are constant with row wise and with column wise, that particular term only will get. In terms of that particular variable, you will get the simplified function. Whichever variable is varying, that won't come in the simplified function, because here that is getting eliminated or simplified. Okay, I hope it is clear up to now why we have considered gray code only in the case. Okay, because in order to do the easily, we no need to do this kind of simplification, but that kind of simplification will take by the K-map, since we have placed the gray code. Right. So up to here, I hope it is clear for everyone. Now let us discuss the simplification here using first step is place the ones with respect to term position. The ones with respect to term position. Place the ones in general. We are having Boolean function. Function is IM. After doing simple get SO. So for the timing, I am discussing with respect to IM. We are getting SO. Whatever the procedure here we will discuss, same procedure will applicable having pi capital M. That time you will get pivot. Okay. Here I have told once, because for those input combinations we are getting output as 1. Okay. If you want to get POS, that time you have to consider max terms, how to place the output. Okay, for the timing I'm the procedure with respect to min terms. Okay, similar procedure will applicable with respect to wherever I mentioned term, just replace with max term. Wherever I mentioned once, just replace. The first step is, if you are having Signam form, okay, the given first of all place the ones in the respect to position. Place the ones after that. Do all the possible groupings of all the possible of adjacently placed ones all the possible of decreasing powers of powers of 2. do all the possible grouping of adjacency placed powers of. Say for example, suppose if you have considered two variables, so here first of all you will check for whether grouping of square edges possible or not. Suppose 2 square means what? 4. That means if having all the 4 minterms are 1, then you can do the grouping of all the 4 ones together. Sum of all the minterms is nothing but 1. Okay, that is not possible. Then go for 2 power 1. That means grouping of two adjacently placed ones. And then you can go for 2. So like this, how to check from highest power of 2 to the least. Finally, if you are considering 3 variables, for 3 variables, you can check from 2 power 3, highest number of variables, right? That one you can power 3, then 2 square, power 1, power 0. And similarly, for 4 variable K-map, start from 2 power 4, then check for 2 power 3, square, power 1. This way, from highest power of 2 to the least power of 2, we have to check whichever ones are adjacent. We have to always check for the highest power of 2 possibility. If not possible, then only we will go for lower power. Okay. Why like this? Why not? We'll talk. Say for example, we're having, suppose in this 3 variable K-map, suppose the second row, entire second row if you're having 1, suppose entire second row is having 1s. So here actually 4 ones are there. 2 square is nothing but 4. All the 4 ones are adjacent. All the 4 ones. But okay, here in this case, instead of doing grouping of all the 4 ones like this, suppose you have done this. Okay, 2 power 1. That means you have done grouping of 2 1. Then you have done grouping. Okay. So from this grouping, what you got? AB bar. And tell me what is the term you are going to get from this particular. Regarding this grouping, we already discussed. Just give a try. What is the term you are going to get if you do the grouping of these two? Yes, very good, Isaki. Very good. Here for this grouping, when you observe row wise A value is 1. Value is 1. And column wise, value is 1. So from this grouping, you are getting this term. From this grouping, you are getting this term. Now what you have to do? So here actually I am considering one example. That means 4, 5, 6, 7. 4, 5, 6. According to the K-map, when you observe this entire row, whatever the terms you are having, all the minterms are in. But instead of doing grouping of 4 ones, you have done individually grouping of 2. From there, you are getting like this. What you are getting? You are getting A into B for S. You are getting the term. Now from these two, you take A as common. Then B bar plus B what? 1. B bar plus B. So that means we are doing the lowest power of 2 adjacently placed ones, instead of doing, whenever there is a possibility of doing higher power of 2, that time instead of doing like that, if you are doing the lower power of 2 adjacently placed ones, okay, that time what you have to do, you are doing once again what is the simplification we have done earlier, okay, with the help of basic. Once again the same simplification you have to do, right? So in order to overcome or in order to avoid such kind of simplification from our side, we are using the K-map and we are placing the ones, right? Such a way that any 2 minterms, if you consider, all those minterms are adjacent, right? So with the help of gray code, so that's why whenever there is a possibility of doing grouping of higher possibility regarding in terms of adjacent placed ones in powers of 2, always go for higher power. Whenever the higher power of adjacent placed ones not possible, then only go for lower. Say for example, you could have done grouping of 4 ones like this. Or done grouping of 4 ones like this. Now for this entire row, A value is 1. For this entire row, A value is 1. That means directly you can write it. Because for this entire row, A value is 1, but column wise, B values, C values are changing. Okay, whichever variable values are changing, that won't come in the final answer. So directly you can write A. Okay, but if you are doing lower power of 2, lower power of 2 adjacently placed ones you are doing, after that, how to do the simplification. Okay, I hope it is clear for everyone. Here, when you are solving the question with the help of 4 variable K-map, first of all, you will check whether grouping of 2 power 4 edges is possible or not. That is possible, then you can do the combined grouping of all the 16. If you are doing grouping of all the 16 ones, get simply because sum of all the min terms is 1. Similarly, even you can observe here. Here also, suppose if all the 8 cells, if you are having 1, if you are doing grouping of all the 8 ones, simply you will get 1. Okay, or instead of that, if you are doing grouping of 4 ones here, and similarly if you are doing grouping of 4 ones, from here I got A. Similarly, if you are doing grouping of first row, you are doing entire grouping of first row, from there you will get A bar plus A, but 1. Okay, like that simplification you have to do. Just in order to avoid that, always try to check for highest possible grouping of edges powers of 2. Whenever higher possibility here, do that grouping. Okay, and like that continue. Whatever the possible groupings, higher order possible, do all the possible groupings. After that, check for lower order grouping one by one. And if any possible groupings are there, lower order. Provided whenever higher order grouping is not possible, then only you can do. Say for example, if you are having 2 ones here, if you are having 2 ones here, in that case, we cannot do combined grouping of 4 ones because these 4 ones, M0, M1, M6, M7, those 4 min terms are not adjacent. That time only we will do grouping of 1 here, 2 ones here. Whenever higher order possible grouping is there, always do the higher order. Whenever higher order possible grouping is there, that time, say for example, in this case, grouping of 4 ones possible. In that case, no need to do the grouping of 2 ones here, 2 ones, because that is like redundant, right? I hope it is. Similarly, for 4 variable, you will check for 2 power 4. Not possible, then go for 2 power 3, then 2 power 1, 2, like that. From highest power of 2 to the least. Okay. Now why we are considering only in powers of 2? Why not any other power? Any idea? Why we are considering only in powers of 2? Why not any other power? Why not 3 power or example, if you observe here, say for example, when we have done grouping of 2 adjacently placed ones, when we have done grouping of 2, that time what happened? Initially, when you consider M4, M5, consider M5, and every product term, you are having 3. Yes, sir. Yeah, you are almost clear. Okay, you can observe here. Here M4, M5, initially you are having what? 2 product terms. In each product term, you are having 3. Now, if these 2 min terms are adjacent, then after doing the simplification, and you are getting one product term. In that product term, you are having 2 literal. That means one literal getting min, one literal is getting minimum. That means here in this particular example, M4, M5, if you are doing, that means you have done group of 2 power 1 adjacently placed ones. Okay, we are doing grouping of 2 power 1 adjacently placed ones. Whatever the power here you are having, that many literals are getting. You can observe for 2 min terms, 2 adjacently. After doing simplification, we are getting only 2 literals. That means 1 literal is minimum. Similarly, when we have done grouping of 4 ones, means what this? Here we have done grouping of 4 adjacent ones. Now the final answer we got A. That means here we are having only 1 literal. That means 2 literals are regarding B and C. Correct? So in this way, suppose if you are doing grouping of all the 8 ones, if you are doing grouping, from that grouping you will get final answer as 1. That final answer 1, how many literals? Suppose you are adding all the min terms, you're adding all the minterms. From there, you will get final answer as 1. That is a constant. That constant 1, how many letters are having? Do we have any literal constant 1? No, right? See, what is literal? Either the variable normal form and the corresponding complement. Okay. When you're doing grouping of all the 8 ones, all the minterms, that time you're getting constant 1. In that, you don't have any literal, right? 0 literals. Okay. So now you can observe, if you have done grouping of all the 8 ones, okay, here in the power you're having 3. That means in the minimized function, 3 literals are getting minimized. Okay, since the given function is three variables, the minimized function 3 literals are, that means don't have any. Yes, very good. All A, B, C are eliminated. Very good, Isaac. Okay. So in this way, suppose, say for example, suppose if you have done, suppose only M0 is there. Okay. M0 value is 1. Okay. Remaining all are zeros, say for example. Okay. That means there is no possibility of doing any higher order grouping of 2 adjacent placed ones, right? Obviously, we will do individual grouping M0. Okay. So in that case, in the minimized, from that grouping, you will get the term like A bar, B bar, C bar. In that case, you are having 3 literals, right? So in the minimized function, you're having all the literals, or you can say that you haven't minimized any literal. While you are getting the minimized function, you couldn't eliminate even literal, right? So that's why here the power indicates whatever the power value you're having, that power value is giving the indication that how many literals are getting the minimized while you are doing the grouping of. I hope it is clear. Okay. For all the K-maps, whatever the power value here you're having, that is indicating the minimized function from that grouping, how many literals you want to eliminate. Yes or no? Say for example, if it is a 4 variable function, what is your intention? If you want to get the simplified function, first of all, you will give the try. Not to eliminate all the 4 variables. Yes or no? Or all the 4 literals. Okay. That's why we are checking for grouping of 2 power 4 additional first step. Not possible. Then only we are trying to eliminate 3 literals. Correct? Try to eliminate 3 letters. When that is not possible, then go for eliminating 2 literals. Not possible, then go for eliminating at least 1 literal. Okay. If not possible, then worst case, like suppose if any minterm you are having only 1, to adjacent to that particular minterm, if there is no other 1, okay, that time in worst case, you are getting the minterm itself as the final answer, right? So in that case, you are not eliminating. So that's why here you are getting in powers of. I hope it is clear. This power value is giving the indication that how many literals you are able to eliminate in the minimized function, while you are getting or while you are doing the grouping of. Okay, that's why here we are starting from highest power and then we are going for least power in the, right? So I hope by this time it is clear for everyone. Okay, why we are doing the preference from highest power to the least power? Why not the reverse? Okay, fine. So first step is place the ones in the respective minterm position and then do all the possible grouping. Do all the possible grouping of adjacently placed ones increasing powers of. And one more important point, whenever there is a possibility of doing higher power of grouping of adjacently placed ones, that time you should not do the lower power. Just like say for example here grouping of 4 ones if possible, then that time you should do grouping of 2 ones like this. That point you can make it. So these are the 2 steps. After that, you will get the minimized function. Minimized function equal to essential prime implicant plus prime implicant. Prime implicant brackets optional. Minimized function equal to essential prime implicants plus prime implicant optional. Okay, right. So what is prime implicant? What is essential? Just write down the product term obtained product term by doing the product by doing of adjacent based ones by doing the of adjacent decreasing powers of prime implicant. Prime implicant. So for example, in the previous case, suppose if you are having only two ones here, okay, then from this grouping you are getting this term that is called prime implicant. Similarly, if you are having two, to do the grouping of two ones, from there you will get one product term that is prime implicant. Suppose of only two ones here, together if you are having four ones like this, in this case we will do the grouping of four ones. From there you are getting one simplified term that is called prime implicant. This way, from highest power to the least power, okay, whenever highest power is possible, higher power is possible, do that grouping. Say for example, in this of these four ones, so in this way, from higher order grouping, lower order grouping, whatever the possible groupings are there, do all the possible. From each grouping, whatever the product you are getting, that product term initially we will call it as prime implicant. Initially we will call each product term that you are getting from each grouping in this particular order called as prime implicant. Now, that prime implicant we will rename as essential if it is compulsory. If it is compulsory, then we will call that prime implicant as essential. Okay. So for that, one specific condition is that condition satisfies, then only we will call that prime implicant essential. Otherwise, we will call simply as prime. A prime implicant said to be prime implicant essential prime implicant prime implicant prime implicant prime implicant said to be essential at least till one having only one group. Till one only one group. Okay. So regarding this particular essential prime implicant, you will get the clarity with the help of one example. So regarding prime implicant, there is no confusion. With the help of this particular possibility, whatever the grouping of edges from each, whatever the term you are getting, that is the prime implicant. Now, among those prime implicants, okay, some of them or maybe all of them, we can call them as essential, provided if it is satisfying condition. So regarding this condition, get the clarity with the help of now. Okay, we have to simplify by using, since it is a three variable function, we have to draw the three variable K. First of all, draw the variable K. So here in this function, that the variables are created. So that means so here you're having the Boolean function form. The first step is what? We have to place the ones in the term position. So here first one is 0, not there, next 1. So for reference, I am placing here what are the term numbers, suffix value you're having, just for reference. 1, 2, 4, 5. Okay. Now just observe these numbers, and wherever these numbers, if it is there in the given function, just consider that particular cell value as 1. Here 1 is there, then 3 there, and 7. So for the given function, you are having 4 minterms. So for those combinations, for those minterm positions, the 1. Now, first step we have done placing of ones. Now the second step, since the given function is a function of 3 variables, first you will check for grouping of 2 power 3 edges placed ones. Grouping of 2 power 3 edges. No, not possible. Because the given function itself, you are having 4 minterms. How it is possible to the grouping of 8 edges ones? It's not possible. Right? Then go for 2 square. Grouping of 4 adjacently placed ones. The function you're having 4 minterms, but all the 4 minterms together not adjacent. Say for example, if you're having 1 here, then of 1 here, if you're having 1, you could have done grouping of 4 1. Okay, right. But here grouping of 4 adjacently possible. Go for 4 1. Yes, in this grouping of 2 power 1 edges possible. Now tell me how many grouping of 2 power 1 edges possible for this K-map. Just observe this K-map and tell me how many groupings you will get by doing the adjacently placed 2 ones. 4 1 is but 2. Yes. Yes, you can observe here. Yeah, okay, I am asking all the possible groups. All the possible groups. Here you have to do all the possible groups by whichever are 2 adjacent placed ones. So here in this observe, you can do grouping of these one possible group. Okay, and then you can do grouping of these ones because these two, that is one grouping, and then you can do grouping of these. So for this K-map, grouping of 2 adjacently placed ones, like that 3 possibilities. Yes, very good, very good. Okay. So whatever the number of possible groupings are there, do all such. Okay. Now from each grouping, get one product term. So for this particular product term, for this particular group, row wise x values, that means or and column wise z values z. Okay. Similarly here for this particular group, row wise x value is 1 and then column wise y value is 1, and then for this column grouping, row wise x value is changing, that won't come in the final answer. But column wise both values are constant, y value is 1, z value is yz. Okay. So for this K-map, we are getting 3 possible groupings of adjacently placed 2 ones. Okay. So from each grouping, whatever the product terms we are getting, initially I will call one as implicant. Actually, I will call implicant. Up to this point, whatever the procedure I have mentioned here, okay, what is the procedure here I have mentioned regarding first two steps we have done, and then regarding implicant also, I hope it is up to this. Now you have to see the one important thing. Okay, just observe. Say for example, if you consider this party grouping, white color grouping, okay, for the timing if you ignore this party grouping, white color grouping. So for this particular one, do we have any other grouping? For the timing, if you have removed this white color grouping, for this one, whether do we have any other? No. That means this particular grouping is mandatory, compulsory. Yes or no? Like that, we are having minimum one, still one, or it can be more than one also. Okay, right? But if at least single one, except that grouping, if there is no other grouping, that means that party grouping is compulsory. So we will call that whenever that group is compulsory, that implicant I am renaming as essential. Similarly, see, if you observe with respect to this one, you remove this party grouping. This one was covered by some other grouping. But with respect to this one, except this grouping, there is no other grouping. That means it is compulsory, mandatory. Clear? Now, with the help of with this understanding, now if you observe this party grouping also, you remove this white color grouping. For this one, we don't have any other grouping. That means it also now just observe this column grouping. Whether this grouping is compulsory or not. Is it compulsory grouping or not? Yes, you can observe here. You remove this grouping. This one was covered by some other grouping. This one was covered by some other grouping. Right? So this grouping, this grouping is not at all compulsory. Correct? Yeah. So that means I will call initially each product term, whatever we are getting, those product terms we will call as implicant. After that, based on the condition, that means if the grouping is compulsory, I have renamed as, okay. Otherwise, the remaining implicants you can call simply implicants. So that means for this particular K-map, we are getting three implicants, out of which two are essential. Now let us write the minimized function. Minimized function will get f of xyz equal to, first of all, we will consider the essential implicants. That means x bar z plus x bar. Now let us check whether this grouping, whether this particular term we have to consider or not. Okay. Say for example, x bar z, if you observe, we have covered these two, and with the help of this group, we have covered these two. For the given function, you are having 4 min terms. Okay. All the 4 ones we are able to cover with the help of these two essential only. With the help of these two groupings, we are able to cover all the 4 ones. That means this particular grouping is not at all required. Why? Because our intention is what? We want to get the simplified function or minimized function. In the minimized function, we are able to get the minimized function with the help of 2 terms by unnecessarily 1 more term. Correct? So that means this particular implicant, now I will call or rename as redundant implicant. This K-map, this particular grouping is not at all required in the minimized function, or otherwise you can say that this particular term is unnecessarily present. Suppose if you are adding this term also, that means the term, even if you are ignoring the term, with the help of these terms, you are able to get the minimum. Okay. So that means for this given K-map, you are having 2 essential implicants and 1 redundant implicant. We are having 3 implicants, out of which 2 are essential compulsory groupings and the other one is not at all required. Okay. I hope it is clear. Now suppose if you have considered this particular one also, for example, considered all, then in that case, x bar z plus xy plus yz. Suppose if I have given the function like this, suppose if I ask you to simplify this function, by using which law you can do the simplification of this? By using which law you can do the simplification? Any guess? I have already mentioned in the beginning of this particular chapter, among all the laws, only one law is the most important and powerful law among all the laws. What is that one? Yes, very good, Isaki. Very good. It is consensus law. Consensus law, right? Consensus. Here, the last term, if you consider, here y is present in this particular term, z is present in this particular term. Here in the last term, x is missing. So that is present here, normal form. Its complement form is present. This is the consensus law. Regarding this, we already discussed the proof in the beginning of this particular chapter, and even with the help of K-map, we are getting the proof for same consensus law. Okay. So whenever the question is regarding the prime implicants, essential, redundant, etc., that time you will do all the possible groupings. But whenever the question is regarding minimized function, that time when you do good number of questions regarding K-maps, with the practice, you can avoid this kind of grouping. You might have done only this grouping, because the moment when you are trying to draw this grouping, you can observe that that is redundant. Even in the absence of that one, you can get the minimized function. Okay, right. So I hope all of you got the clarity regarding prime implicants, essential prime implicants, and redundant prime implicants. Okay. So in this particular session, we have discussed regarding the concepts of Boolean algebra, and then we have started the K-map, and then we have discussed procedure, and with the help of procedure, once again I have given the proof for consensus. Okay. So the next week on coming Thursday and Friday, we'll be having the digital classes. So on coming Thursday, we'll continue further on K. We'll discuss variety of gate questions. Okay. We'll discuss all the possible methods there, and then on Friday session, we'll start the logic gates. I hope this session is very much helpful to all of you. Thanks for watching this video, and all of you kindly share this with all of your friends. All in the next.